Aloha. I am Kevin Bowyer, and my greeting is aloha, and I'm wearing my Hawaiian print Notre Dame shirt today because I am recording my part of our group tutorial, which will be presented at WACV 2022 in Hawaii. The overall tutorial title is Human-Machine Pairing to Improve Computer Vision, and I'm giving this along with my colleagues from the Computer Vision Lab at Notre Dame. My particular part of the tutorial presentation is titled, Do you want a smarter deep CNN? Then train it using human salience. To set the tone for my part of the tutorial, I want to pose for you a visual classification task. Think about how you would solve this task from the examples that I've given you here. On the top row, I've given you 3 iris images, and I've told you that the person is not wearing a contact lens in these 3 images. In the bottom row, I've given you another 3 iris images, and I've told you that the person is wearing a clear contact lens in each of these 3 images. The task is from these images to formulate an algorithm that you would use when you examine a new image to decide how to classify it as either not wearing a contact lens or wearing a contact lens. If you haven't done research in the area of iris recognition and spent some time looking at these sorts of images, this probably seems like quite a difficult task, especially from the small amount of training data that I've shown you here. But if I were to give you some hints about where to look in the image, if I were to say, to solve this particular problem, you should look in the area of the image just to the side of the iris region and into the white of the eye, the sclera of the eye, and look there for information that would tell you whether or not the person is wearing a contact lens, then the problem might begin to seem a little bit easier. If I were to tell you for the second pair of images there, the second column of images, again, look at the region of the image just to the side of the iris and into the whites of the eye, and see if you see information that would help you to solve this classification task. And again, for the third column there, if I were to tell you, look at the region of the image to the side of the iris region and into the sclera and look for a clue there, and then you begin to generalize across these 3, and perhaps you've noticed there's a curve there, and a curve there, and a curve there that could represent the edge of the contact lens resting on the sclera, and you see nothing like that in the corresponding regions of the other images. And now you might have in your mind an idea for how to approach this problem that you feel confident will give you reliable results in classifying future images that you see. So the point from posing this task to you at the start is so that you can see some iris images, because a lot of my part of the tutorial is going to be illustrated through iris recognition and presentation attack detection for iris recognition, but also to plant in the back of your mind the idea that an apparently difficult visual task can be made easier when you have hints on where to look in the image to find the information that's relevant to solve the problem. Where are the salient regions in the image to acquire the information you need to solve the problem? Okay, I'm going to say a few words about iris recognition in general, and then I'm going to, for my part, move on to presentation attack detection, open set iris presentation attack detection, human ability at iris presentation attack detection, and then to the main topic for the tutorial, training a better CNN using human salience. We will take a break in my particular personal presentation and switch out with a colleague in between iris recognition and presentation attack detection. I'm showing you here another iris image. This is a commercial sensor acquired iris image. This is representative of the type of images used in all commercial iris recognition technology. It's roughly 480 by 640 in size. It's acquired using near infrared illumination, so there is no color image here. You don't see the color of the eye. You see the eye texture and the skin texture as it's seen with near infrared illumination. There are controlled imaging conditions. The distance from the sensor to the eye is controlled. And the quality of the focus is controlled. And it's well accepted in the field of biometrics that one image of this type, this quality, can be turned into an identifier, a personal identifier for this particular iris that will allow 1 in a million false match rate combined with only 2 or 3% false non-match rate. To be more clear about this combination of performance metrics here, the 2 or 3% false non-match rate implies that 97 or 98% of the time that you go to use iris recognition to get into something, to access something that you're supposed to be allowed to access, it will work correctly for you the first time. Only 2 or 3% of the time will you have to retry to access something you are entitled to access. At the same time, the chances of someone else randomly showing up, saying that they are you and being able to access the resource that you are entitled to are only about 1 in a million. In other words, 1 million people would have to try to be you with zero effort as imposters in order to break into your account. This combination of 1 in a million false match rate and just 2 or 3% false non-match rate has seemed quite extreme in biometrics. And for some period of time after iris recognition was launched, and I'll credit the launching to John Dogman, who's pictured here. So we're standing outside a building in Cambridge in the UK. John is recognized as the father of iris recognition. His early patent demonstrating that the problem could be solved, or illustrating a way to solve this problem of matching iris images, and his argument that the false match rate and the false non-match rate combination that I've described could be achieved. Took a while to catch hold in the field of biometrics, but everyone who has worked in iris recognition accepts now that that sort of combination of performance metrics is achievable and is achieved, in fact, by commercial technology. And I illustrate here a quote from one of John's early papers. The binomial cumulative from 0 to just 0.3 is 1 in 10 billion, or roughly the planetary number of human eyes. John was given in some of his writings to making statements like this, implying that iris recognition has the raw power to be able to distinguish between all of the individuals on planet Earth, the planetary number of human eyes. This seems extreme, but for the last decade or so, the go-to example of practical working biometrics that incorporate iris recognition and solve a problem at huge scale has been the unique ID authorities Aadhaar recognition program in India. I've pulled some numbers here. In November 2021, Aadhaar was well over 1.3 billion individual persons enrolled in a national scale ID program. Aadhaar actually uses 10 prints, 2 irises, and face recognition, but I think all observers agree that had iris recognition not been a part of the Aadhaar program, it could not have been a success at the scale that it is. Now, 1.3 billion people is not truly the entire population of planet Earth, but there are other efforts. This one I've pulled out is just getting launched that that have the ambition to use iris recognition to enroll essentially everybody or potentially everybody on planet Earth into a biometrically enabled system. This effort is called WorldCoin, and the former CEO, the current CEO of OpenAI and former president of Y Combinator is one of the people behind this. The idea is that by taking both of your iris images, we'll be able to give, WorldCoin will be able to give individual enrollment to potentially everyone on planet Earth. For some number of the early enrollees, they will be given a small amount of free WorldCoin, and this will bootstrap a new economic paradigm across borders, allowing everyone on Earth to participate in an economic system as an alternative to the current system. So very ambitious iris recognition enabled global ID program. The lesson from this first part of my material is that iris recognition has powered and will power some extreme concepts of universal ID, at least planet Earth ID. Now, the next part of my presentation within the tutorial will be on presentation attack detection, but I will pause for a moment and let my colleague Daniel Moreira present, and then I will come back and join you for presentation attack detection and presentation attack detection in the context of iris recognition.